Right, in the last video I started writing down the example x plus 3 quantity to the second power, and the video cut out. So I'm going to continue that example because it's a very important one. You'll come across problems with this situation in them quite often. I am going to go to a separate sheet of paper because I'd like more room to show you this one. So we're continuing introduction to factoring with a binomial squared. Here is what you don't want to do. This is the wrong answer. Okay, I'm going to write not equals to, for this is not going to be the correct answer for how to do this. The wrong answer is x squared plus 9. You don't just square the first one and square the second one and then add the two together. We are not doing this because these two things are not being multiplied. If we had 3x squared, then yes, we would distribute the 2 to both of the factors inside, and we'd get 9x squared. We wouldn't get this, because we're not starting out with that. These two things get confused all the time. So let's find out the right way to do a binomial squared. So x plus 3 squared, we know it's not this, so let's find out why. It's because x plus 3 squared means x plus 3 times itself. It means it's times itself, so we need to expand it. We need to write it out like this. Well, then you can clearly see it's a FOIL, or a box problem. We need everybody in this parentheses to get multiplied by everybody here. So this times this times this, 3 times the x, and 3 times the 3. Or you can set up the box method, 3 times x, 3 plus x on top, and 3 plus x on the bottom. Okay, I'll do both methods for you quickly. By now this should be old hat to you. X times x is x squared. X times 3 is 3x. They're both positive, so we write plus in between. Now this 3 needs to get multiplied by that x, and we get 3x there again. This is a special situation, and 3 times 3 makes positive 9, or plus 9. This time the two inner terms are exactly alike, and you know what? That's what's going to happen every time you have a binomial times itself. You're going to have the first term squared, boom. You're going to have the last term squared, boom. And you're going to have the first and second term added together and then doubled. So we're going to get x squared plus 6x plus 9. Now does that look like this? This one's missing the inner term that happens when both things get multiplied by each other correctly, as in this example. Alright, let's do it with the box method. I got my 3 plus x across the top, 3 plus x across the side. It's this problem just written out in the box method. 3 times 3 goes in the first box. 3 times x goes here. 3 times x goes here. And x times x goes here. As usual, we get two like terms on a diagonal. Those two like terms add up to 6x. So let's add up our terms. We've got the x squared, we got the plus 6x, and we've got the plus 9. Now I could put the 9 first. It could be 9 plus 6x plus x squared. Order doesn't matter on these polynomials. We usually like our x squared term first, our next power of x second, and then any plain numbers last. So again, both methods work to give us the correct answer. Please try not to make this mistake and just square each thing inside. Remember, both x and 3 need to get multiplied by another x and 3.